Hi all. So welcome to the Stewardship Network's monthly webcast. I'm Lisa Brush and really pleased to be here with you again on this second Wednesday of the month, as we are with each and every second Wednesday of the month during the Eastern Time Zone's noon hour. Really pleased to be here with Mike Kost, a friend and colleague, talking about factors influencing oak regeneration. So a couple different questions for you. Drop in the chat, as people are doing right now, where you are tuning in from, and then drop into the chat your bet. I was just telling Mike that we just finished our successful virtual 2022 conference, and Mike was asking, what do you think you're going to do in 2023? So the Stewardship Network has an annual conference in January. Place your bets. What do you think? So Martha and Eric, great to have you here from Ada. Leslie, good to have you here from Hamilton, Ontario. Peter, great to have you with us again. Always great to see new folks and returning folks. I'm going to do a little intro about what the Stewardship Network is. Margot, thanks for your work as a volunteer photo monitor in Bird Hills. I've got a connection in Toronto that wants to make a connection on monitoring and how you do that in an easy way. So I'm going to be reaching out to some of you with that question. Let me tell you a little bit about the Stewardship Network. We are an 501c3 nonprofit with an award-winning 20-year history. We have our 30 place-based member communities, and as you all know, we work with thousands and thousands of partners from all volunteer NGOs to international NGOs, from small privately owned consulting companies to international consulting companies as well. Our mission is to connect, equip, and mobilize people and organizations to care for land and water in their communities, and we do that in lots of different ways. So we mobilize people, as I said, through our member communities, making collaborative ecological stewardship accessible to all. We mobilize in lots of other ways as well. We are out on the ground doing stewardship and increasing ecological health. We do habitat management, biodiversity, water quality, and watershed restoration. We work on regenerative ag, and we also do provide some of that backbone support to you all on strategic planning, organizational development, and business planning. One of the really fun things we love to do is help increase your local capacity, whether you're part of our member communities or sometimes as a side consulting project around strategic planning. We equip people in lots of different people and organizations in lots of different ways so that people can be out on the land, pouring thousands and thousands and thousands of annual volunteer hours into our ecosystems doing stewardship. We equip by providing lots of other tools around training, these kind of free online monthly webcasts we've been doing for more than, it's like 18 or 19 years now, back when we didn't do this all the time. We provide backbone support to equip people around event registration and communications. As we say, we want to keep you all out on the land, connecting with each other and doing ecological stewardship. And then we connect you. So we have, as I said, I just had an inquiry from Toronto around ecological monitoring and how do you do that and how do you do that in a simple way. And so we're going to connect that person in Toronto with some of you all online to share some of the lessons that you've learned and the practices that you do. So we've got a great, you all are a great tree canopy of flowering buds that we can share the information from you and the work that you do and the lessons that you've learned. And we also connect in lots of ways. Our monthly webcasts, as we said, if you're new to the Stewardship Network monthly webcast, welcome. As we said, if you tuned in right at the top of the hour, go ahead and drop into the chat where you're tuning in from. We have a nature photography competition that has thousands and thousands of photos submitted from all over the world. We have our distributed leadership program. We have a monthly discussion group in one of our member communities that's been going for more than 25 years, where we meet each and every month and talk about all kinds of different stewardship topics. You all are out in your communities with community engagement events. And I want to also thank you all online who are financial contributors to the Stewardship Network. Your tax-deductible contribution helps enable us to provide things like these free online monthly webcasts and connect, equip, and mobilize all year long to do that. So again, thank you so much. You can go to stewardshipnetwork.org and make a donation. As I said, I'm Lisa Brush, really pleased to be here on the second Wednesday of the month. So again, if you're new, you can drop it into your calendar as a recurring event. And really pleased to be here with Mike Kost, who's with the University of Michigan Mathi Botanical Gardens at Nichols Arboretum. So Mike, thanks so much for joining us. Looking forward to talking about oak regeneration.
Glad to be here. Okay, so I'll be sharing you results of a 3-year study looking at what factors influenced oak regeneration, where oak regeneration succeeded and where it failed. And I got interested in this topic when I was in graduate school reading papers. One winter, I immersed myself in 30 publications, 30 papers on oaks and oak ecosystems, oak forests, oak savannas, oak barrens. And one of the things that really surprised me was that in the 1940s already, ecologists had started to write about oak forests. These are forests dominated by black oak, red oak, white oak in the forest overstory in the canopy, and the understory was filling up with red maple and sugar maple. So they were already documenting this change or potential change to a future condition, to a mesic forest. So this affects many other species, and I'll mention a little more about that in a minute. But when I came to Michigan, I was doing ecological surveys, and I was finding sites that look like this up in the Grayling Outwash Plain in Crawford County, where they had done a thinning of the overstory and had great success with oak regeneration. But mostly what I was seeing is sites that look like this in Berry County on a moraine, where the forest overstory was still white oak and black oak predominantly, but the understory, almost all the greenery you're seeing there is red maple in the understory and in the sapling layer. And that's Rachel Steele, one of our field assistants during the year that we sampled in southern Michigan. So you're seeing some large red maple too. It's recruited into the canopy. And when it does that, it forms this dense canopy layer that just blocks a lot of light from reaching the understory. So it has a huge effect on the ecosystem in terms of who can exist and who can't. And oaks, the species I'm going to be talking about today that we looked at are black oak and white oak and red oak and a northern pin oak or Quercus ellipsoidalis and bur oak to a lesser extent. So these are the species that they don't do well, and chinkapin would be the same way, doesn't do well in a dense canopy. So what's the effect on other species? Well, oaks aren't just any other species. Doug Tallamy did such a nice job illustrating this or discussing this in his recent books, The Nature of Oaks and Nature's Best Hope. Those are exceptional books. I'd highly recommend those by Doug Tallamy. But oaks are, they are the classic keystone species because they have a disproportionately greater effect on other species abundance and on species diversity. His work and that of others that he discusses shows that oaks support more caterpillars, the genus Quercus, than any other genus in North America. So they've already documented over 900 caterpillars, and I think that's just the beginning. In the mid-Atlantic region, white oak, our beautiful Quercus alba that's so near and dear to our hearts here in the Great Lakes states. That species some time ago, he had documented 539 caterpillars, more than any other species on a white oak. And the importance of this can't be understated because our songbirds like this chickadee, they can require up to 800 caterpillars a day to feed their nestlings. And to raise a clutch of eggs, to go from, to fledge, it can take up to 9,000 caterpillars. It just boggles my mind. Where do they get those caterpillars? They get them from lots of trees, but primarily the oaks. And we all know about acorns. Surely they feed a lot of species, deer and turkey and bear and quail and raccoons and possums and wood ducks. If they land in the water, wood ducks they're right on them. So yeah, they're critical, and those wildlife populations can fluctuate as oak mast increases, these mast years where there's just, thousands of acorns, to poor years. So they have a huge effect on species. And then the wood lasts longer than maples and other hardwood species. So it has a longer retention time for the snags, for the coarse woody debris, and the leaves support the leaf-eating insects. They provide wood cavities, and the leaf litter is used by dozens of species too. So as well as fungi and lichen. So they're just hugely important. And so I was able to get funded by the DNR to do a 3-year research project looking at where oak production, where oak regeneration was working and where it wasn't, and what were the factors. And I was lucky to be able to hire Jeff Lee right out of school. He just finished his master's degree at the University of Michigan School of Natural Resources under Bert Barnes, and he had studied silver maple. So he was really happy to spend a couple years with dry feet. And Jeff did a great job. He conducted the field work, hired a crew each summer for 2 years and did the field work, did the statistical analysis with lots of help, and did the bulk of the writing on this report. So I'm largely reporting on Jeff's work here. So we sampled 105 sites distributed across Lower Peninsula and stratified north and south. We had 52 northern sites and 53 sites in the Lower Peninsula, and we used Denny Albert's landscape ecoregions to stratify our sampling. And then we further stratified our sampling on the major landforms that support oak in the Lower Peninsula, which are the sandy lake plains. And these are deep areas of deep sand, sometimes underlain by clay. And where that happens, it has a really different effect on the ecosystem. But we tried to find sites that weren't underlain by clay. The Grayling outwash plain here, which consists of large, deep areas of outwash sands, as well as these brighter pink areas, ice contact, which are, let me just stay on this outwash for a minute, and these lake plains. Both of those are very similar in terms of deep sands. They're sorted materials, so we don't find big rocks in them and other debris. It's primarily just sand, and so they can be excessively well-drained landscapes, and they tend to be very flat or just gradually rolling. So generally pretty flat. And so in the Newaygo outwash plain, the Battle Creek outwash plain, and then there's lots of that outwash here in the Ann Arbor Moraines as well. Or the Jackson Interlobate actually is illustrated here. That's Denny's subsection. So the Moraines and the ice contact features, both of those, ice contact, kettle came topography, very broken up hilly landscape. But the composition is similar to the Moraines in that it can be whatever the glacier was carrying is going to be there. It could be clay, sand, silt, boulders, gravel, whatever it's carrying, it's just dumping it there. And it's dumping it in the form of a moraine. It moves forward, stops, and the end moraines are where where the glacier terminated and receded. From that issued just a torrent of water carrying those deep sand, carrying that sand that blanketed the landscape and formed these outwash plains. The ice contact features are where the glacier, a large chunk of ice like the size of the city of Ann Arbor or a college campus, broke off and slowly melted in place. And so it ends up being kind of a hodgepodge, very hilly, with kettle lakes as well. But the composition will often contain some finer sediments, and the same with the moraines. So that's a little bit about how we stratified our sampling. Our field methods included plat sampling of overstory, understory, and ground layer vegetation, measuring tree seedling and sapling height, coring trees in distinct overstory and understory cohort classes to assess the age distribution, and measuring canopy closure, assessing deer browse frequency, describing the soil profile, and we sent off the soil to the MSU soil analysis lab to look at pH, phosphorus, potassium, calcium, and magnesium. And we also recorded aspect, slope, and slope position and slope percent. So, all right. So I'm going to jump right into some of the results. We saw major differences between northern and southern Lower Peninsula, between the north and south ecoregions in soils. So we had a lower soil pH and lower nutrients in the north. They're essentially poorer or sandier soils. I think those of us that have spent time there know this. This is a very so you can see the results here. Sometimes there's half or less the nutrient values in the north versus the south. So that has a huge effect on the plant communities and certainly on oak. And you can see the sand color here. This is a grossly simplified map of the soils of Michigan, but it does a great job of illustrating the dominance of sand in the northern Lower Peninsula and the loaminess of much of the soils in the southern Lower Peninsula. So oak is responding to that. Oak is a great stress tolerator. It's able to tolerate those very low nutrient acidic soils and eke out a living and do quite well. And it loves loamy soils. I mean, you can feed an oak all the nutrients you want. It'll grow nice and big, but it's going to have to compete with other species that also love those nutrients, like the maples. So soils make a huge difference, and I'll say more about that in a little bit. How does oak regeneration vary by north and south ecoregions? Well, we generally had greater regeneration of oak and red maple in the north. So, but we also had greater regeneration of red maple than oak in all the ecoregions. So this is in northern Michigan, and we can see these young oaks in a relatively open overstory, light coming in, oaks regenerating well. And this is showing that there is a lot more oak regeneration than red maple regeneration, even or statewide. So good oak regeneration in north, partly because they're doing a lot of cutting, and they've got these sandy soils and semi-open canopies that they're able to regenerate oak in many places. So how does oak regeneration vary by landform? Oak regeneration is, we found, to be greatest on the sand lake plain and outwash landforms with these deep, droughty soils. And the subsoil of those, so if we dug down a pit, we dug down to 1 meter and we looked at the soil profile, and where there was sand so where sand dominated the subhorizons, that was characteristic of these sandy lake plains and outwash plains, and it was not always characteristic of the moraines and the ice contact. A lot of times there would be a clay layer there that would impede water drainage and provide lots of nutrients, which other species like red maple seem to really capitalize on. So red maple regeneration was greatest on the moraines. And here you're looking at the results of some management, a shelter wood cut in Mason County on a broad outwash plain where there was very good white oak and black oak regeneration. So this was in the Newaygo outwash plain.
And Mike, a clarifying question that Stephanie asked, is the cutting of the actual oaks or cutting other trees other than the oaks?
So shelter wood cut is a type of forestry practice that's commonly used for oaks and species that do best with lots of light. And the way it works is they'll go into a forest and remove a portion of the canopy. It could be like 30%, sometimes 50%, but a portion of the canopy, and give it often about 10 years, 5, it could be longer. Give it time to respond and see what happens. If they like the results, they won't move forward and they'll just stay as a partial cut. And if they think the site would benefit from additional overstory clearance, they'll remove more, either the rest of the overstory or most of the overstory, and go from there and assess it again in the future. So they're taking out all trees. They're leaving some, and they're going in these forests where they're doing that we're looking at have overstories dominated by oak. So they're taking out some oak, and they sell, it's a source of revenue for the U.S. Forest Service, for the DNR. But the goal is to regenerate oak, and forests, some species of oak like Hills oak, Quercus ellipsoidalis, will resprout, and if it's cut before about 70 years. So they'll often time those cuts to be able to easily resprout the oak. So it's not necessarily always coming up for seed, but it's resprouting. And I'll show you a slide or two of that in the next, probably the next slide, I think, or a couple slides. So in Osseo, so a shelter wood cut, which is, think about it as a phased clear cut. And managers don't always finish that. Sometimes they stop it midway through and it's partial cut, but a phased clear cut in which on a coarse end moraine. So this did not work out. You could see the maple in the foreground there. Great maple resprouting and very little northern red oak regeneration, which was their objective. So those Moraines have a little more nutrients and can grow big trees, both oak and red maples. So we dug into the pre-settlement, or better said, the General Land Office survey notes. And I say better said because the land was already settled. Native Americans were abundant. And I tried to avoid that term, but I messed up there, so misspoke. So apologies to anyone tuning in with that, to really all of us, because we don't want to go there. So the circa 1800 vegetation notes, or the General Land Office survey notes, we looked at on the section lines and the section corners, what the surveyors had recorded that was where our sites were. And we looked at different landforms, and I'm just presenting a few sites here to give you the idea of what the general finding was. And this was in southern Michigan. You can see the abundance of oaks, the dominance of oaks, completely dominating sites, circa 1800 and those in the mid 1800s. And white pine obviously was taken out in the in the later 1800s, 1860s, 70s, 80s. And so you can see these, presently white pine is absent. The lake plains are sandy lake plains are dominated by oaks, and the ice contact areas, you can see red for red maple here, is moderate to significant in terms of its proportion of overall trees in the overstory presently. So big differences. And the understory abundance, you can see very high red maple in the ice contact in the understory, and low oak abundance in the ice contact in these sites. So not so much of a change in the lake plain, except certainly an absence of the pines, but red maple did not take off in these sandy, well-drained or excessively drained lake plain sites, but it did in the understory. And we also looked at, so we cored trees and we produced age class distributions, and red maple in so many sites came in about 70, 80, 60 to 80 years, really commonly. So it looks like it's got its start anywhere from 1920s to 1950s in terms of these sites. It's when those trees probably began their existence somewhere in that range. When fire was removed from the landscape, it took some time for them to seed in, and eventually got there, and they're going gun-ho now. So how does oak regeneration respond to management? Well, cutting stimulated the regeneration of both oak and red maple, and cutting followed by burning was more effective than either treatment alone. So, so again, cutting stimulated oak regeneration, but the fires, the following up with a burn reduced red maple abundance. Here's a picture of a site from Berry County, and this occurs on loamy sand soil, so well-drained soil on a coarse textured and moraine, Berry State Game Area, where they had cut it in the late 60s, early 70s, and then about 10 years later, there was a wildfire that came through. The manager described this for me. And it turned out that this site had, the fire had, that combination, the fire had taken out some maples, allowed for the oaks to regenerate. And you can see these double trunked black oaks here. This is an example of coppicing. Oaks will coppice when they're cut, when they're young. In other words, they'll if you cut it and cut it and cut it, they'll come back and come back and come back, but multiple stems. So here you're seeing multiple stem black oak probably from the cut, and then looks like red maple. The cut was probably helpful for regeneration, and then the burning probably helped further set back red maple. And this site, this is a slide I showed you just previously, and this site is about 2 miles straight north on the same moraine. So in this site, it's an unmanaged site. There was no management. And while oak still dominates the overstory, we didn't record a single oak in our understory plots. And a red maple has now reached the canopy. So So on sites that are, anything loamy soils or even these loamy sand soils, without management, the future of these sites, it doesn't look like oaks are going to be the dominant overstory tree at some point in the future. They're long lived and there's still time, but the successional trajectory is set by what's in the understory, absence of large disturbance. So this is a wildfire. So we've talked about management, but we all know, especially in northern Michigan, wildfires aren't uncommon. And in some parts of southern Michigan, like Allegan State Game Area and the Sand Lake Plain there. And so this was up on the Aranac, up in Aranac County, in an area that was historically recorded as pine barrens, where the pines were taken out, and the oaks came back. And what you can see is this was 2 wildfires, and you can see the pulse here. These are 0 to 10 years, a group of saplings, and 0 to 20 years, so anywhere 10 to 20 years old. These oaks, this nice pulse from the wildfire. So on the right soil conditions, right drainage, in these, especially these semi-open canopy conditions, oaks will regenerate. So they certainly have the capacity to do that in the right conditions. We also looked at deer browse, and we saw major differences between northern and southern Michigan. So the south, you can see how much greater deer browse intensity there was. And they were browsing maples as well, maples and oaks. And we also noted that there was more browse with increased deer abundance. Now in southern Michigan, we didn't have, this was data that the DNR had at a county level, which is a very coarse level for a site. So there can be a lot of variation within a county, obviously, of deer browse, but there were no low deer browse sampling sites. So we had medium to high in the south, but we did generally, we did see that the more deer browse, the more deer abundance with the DNR's models, the more deer browse there was, and it was disproportionate. So they certainly could be having effect in southern Michigan. I think our data is I think fairly coarse by comparison to the work being done by Jacqueline Courteau, Baron Blassie, that are using this really novel centennial oak method, where they're actually planting seedlings in sites and then monitoring browse on those seedlings, caging some, not caging others. But they've shown that on the seedlings, or at least Baron Blassie, I should say, has shown about a 15% of those seedlings that are browsed, that he's saying oaks will fail at that level to reproduce. And we're approaching those levels here. Actually, he said 10 to 15%. So we're at there, but this is not just seedlings. We sampled, this is data that goes from 0 to 300 centimeters, so to 3 meters. That's where we recorded that. So it's also recording browse on saplings, and they can resprout, the saplings can, it's the seedlings. So I think a better study. So I'm shooting some holes in this intentionally, because I think a lot of people are very fascinated. We're all very concerned about the level of deer and its effect on regeneration of oaks, which I think it is having an effect. And I'm just saying that this data here looks really significant, and it is, but I think a finer study, a more eloquent way to get at this question is with that's planting those oak seedlings in that centennial oak method. I think it's a better method for answering that question. And in the Ann Arbor area, Jacqueline Courteau is shown, yes, they're definitely having an effect at the Arboretum, the Nichols Arboretum on campus, on the University of Michigan's campus. Just in 2000, she's documented, we've have 57% in 2019, and some years higher, herbivory on oak seedlings. So that's well past the failure rate in those oak forests. But what's fascinating about that site where she's sampling in Nichols Arboretum, it's an oak forest dominated primarily by red oak, some white oak, but that red oak is the dominant there. It borders the prairie, It borders Dow Field or Dow Field Prairie, which is a 13-acre prairie opening along the railroad tracks here in Ann Arbor. And we have to keep oak out of that prairie. So oak seeds into that prairie. Probably blue jays are carrying it and digging it in there, and other squirrels as well. And so under full sunlight conditions, oak is regenerating. So it's not, so there's an additional factors, but under a forest canopy where there is an absence of light, deer probably are like the nail in the coffin, so to speak. Okay, factors contributing to successful oak regeneration. So this is out of a logistic regression model where we put lots of data in and asked, where is oak, what sites or where is oak regeneration? What are the characteristics that define oak regeneration in terms of at a site level? And we measured oak regeneration by oak in the understory, oak abundance in the understory. So sandy lake plains and sandy outwash landforms, that was one of the factors. Low soil nutrients and sandy subsurface soil horizons. So you think about a soil profile digging down a meter or so. If you've got sand all the way down, turtles all the way down, sand all the way down, then you've got these excessively drained conditions. If you put a clay layer there, we did not find good oak regeneration on those sites. Low overstory and understory basal area, especially of red maple. Low ground cover coverage, low shrub abundance, high oak seedling abundance. So is the photo you're looking at here. If you remove that overstory, you've got a lot of oak in the smaller size classes. It's on a sandy lake plain and well-drained soils. It's going to resprout from the cut trees will resprout. The seedlings, saplings will grow quicker because they've got more light and they'll reach that canopy level. Conversely, we're unlikely to see, we did not see good oak regeneration on the moraines and ice contact landforms with heavier textured soils, loams and sandy clay loams and silt loams. And so we just did not see oak regeneration on those sites. So good initial conditions prior to management are essential for successful oak regeneration. These would include semi-open canopy, advanced oak regeneration in the understory. So in other words, there's already oak in the understory, few red maple stems in the understory and overstory, high oak seedling abundance, and low shrub abundance. So that's what you're going for to set yourself up for success. And when you do so, under good initial conditions, a cut will encourage oak regeneration. So this was good white oak regeneration following a shelterwood cut on loamy sand soils on the sand in Aranet County on the Sand Lake Plain. And under poor initial conditions, such as dense red maple or dense sugar maple or dense maple or dense just a dense understory of species other than oaks. If you've got dense cherry, sassafras, elm and ash, and other species, that is not setting you up for success. Or a dense shrub layer, whether it's invasive or native shrubs, a dense shrub layer will impede oak regeneration as well. So under poor initial conditions, a cut or a single burn will encourage regeneration of other species. So here you're seeing red maple. So whether it's a burn or a cut, a single burn or a cut, red maple will, if it's injured, resprout. And you'll end up with just lots and lots of stems of red maple. So, to look at this on a table to help us kind of understand what's going on, you can see 4 landforms there: lake plain, outwash, ice contact, and moraine. We can look across at soil moisture. So that the lake plain and outwash are very similar, and again the ice contact and moraine are very similar. We've got dry soil conditions versus dry-mesic to mesic soil conditions. Soil fertility is low on the lake plain and outwash. You've got stand basal area was generally lower, and this basal area means how big are the trees, how many, and how big are those trees. So you've got very high basal area on ice contact moraines. You grow big trees in those areas, whereas big trees and dense trees in the lake plain and outwash and those infertile soils. Generally lower basal area, smaller trees overall, and the trees just don't get that big. And the understory oak abundance was high in the understories on the lake plain and outwash, and low to absent on the ice contact moraines. Red maple understory abundance, you can see low to medium on the lake plain and outwash, medium to high on the ice contact moraines. So the effort needed for oak regeneration on the lake plain and outwash can be low to medium, depending on how much red maple there is. And if the subsoil is sand, it's excessively well drained, you're really, it doesn't take that much effort to regenerate oak there. But on the moraines and ice contact terrain, ice contact topography, it takes a lot of work to regenerate oak. You're going to have to really go in early and begin to prep that site. So the probability of success is very high on the lake plain and outwash, and mixed, generally I would say low to mixed on the ice contact of moraines. So prioritizing restoration and management efforts at a statewide level. So if you have limited resources, or even within a county or a large land, if you have lots of land that you're managing, you can and limited resources, but you're concerned, you want to keep oak in the mix, you want to prioritize your management efforts, then it would behoove you to concentrate your efforts on sites with the highest probability of success, which are these droughty, sandy landforms with low soil nutrients and subsurface sands, subsurface soil horizon of sand, and sites with advanced oak regeneration already in the understory, a semi-open canopy, and few red maples in the understory and overstory. But we all know there's a lot of land, especially in southern Michigan, that doesn't fit this at all. So sites like what you're seeing here with really dense understories with lots of red maple and lots of shrubs, sometimes lots of invasive shrubs, sometimes just lots of native shrubs. They're beautiful forests. They're absolutely gorgeous forests. The overstory is dominated by oaks, red, white, black typically. And they're on loamy soils. They're on soils with sandy loams, sandy clay loams, silty loams, loam soils. So lots of fine textured sediments, lots of nutrients. They grow big trees. They can grow big trees quickly, and lots of diversity of species. So how do we deal with those sites? Well, before attempting to do any canopy manipulation, and I would suggest before even prescribed burning, initiate and sustain control efforts for red maple and invasive shrubs prior to cutting. And the reason I mentioned burning, and if you're capable of doing burning on a regular basis, that might be fine, but red maple will resprout. So our data, we looked at the number of stems, and our data shows red maple sprouts. So it really is skewed to like resprouting. So you get this great effect of like red maple density in stems. So it probably, those stems generate probably more leaves than a single stem. So initiating control efforts for red maple early on, that's what we found to be, that's what we would advise. So, and invasive shrubs, yes, remove them, thin the understory of species that are non-native and the maples, and then locate existing oak saplings and understory trees and remove nearby competitors. So this is a standard forest management practice used in selective logging of northern hardwoods. Sugar maple is an example. So they'll go in and look at where are the specimen trees that they want to harvest sometime in the future, and they'll evaluate the forest canopy around that. They'll then go in with a selective cut to take out trees, to harvest trees, but taking care to keep their specimen trees, essentially, to not taking care to leave the trees that they want to be the future canopy. We could do the same thing with oak. I don't think there's anyone doing that, but certainly we can look for the understory oaks that we want to assume the canopy and begin to do standard forest management practices to allow to facilitate that understory oak reaching the canopy. Secondly, is we can, or along the same lines, is we can manage the gaps for oak. So oaks, forest gaps occur due to wind throw and snap off. So a tree blowing down or the top snapping off, to ice storms will thin the canopy, as well as occasional insect outbreaks. Gypsy moth will thin the canopy. And we can take advantage of those gaps, and trees will begin to grow in from the sides, and trees will race to see who can get, they'll race for the gaps. They'll grow rapidly to try to assume that gap. And you can do some forest management practices to simply allow, if there's an oak in that gap, or if you can plant and cage an oak in that gap, that would maybe take some time. But if there's already an oak sapling, an oak seedling, an oak understory tree, you can remove other competitors and allow that oak to reach the canopy gap. And then initiating a prescribed burn program with frequent rotations. We're saying 1 to 5 years. Ideally, you wouldn't burn every single year the same site or the whole site every year, to allow for the invertebrates to recolonize recently burned areas. So we have some refuge for recolonization by invertebrates and other species. But the idea that burning frequently enough to keep the red maple seedlings at bay, oaks will often resprout, and then taking some breaks, allowing for those seedlings to rapidly grow once they've developed their root systems, which they spend time early on developing. Oaks will spend a number of years developing a good root system, and once they have that, they can grow rapidly. Tom Crow showed that red oak, for example, once released, was able to grow 2 meters in 1 year once it had a good root structure. If there was a gap, but there was enough light for it. And lastly, but not least, it's critical that we've reduced regional deer densities. And so deer are in southern Michigan. We show that they're having an effect. Jacqueline Courteau's work at Nichols Arboretum in Ann Arbor Park showing, they're having an effect, a significant effect on oak regeneration in our oak forests. So reducing deer densities, and if we can't do that, or site specific, where possible, even caging younger oaks that are still below the browse line, especially seedlings, to allow them to get up to that sapling range where at least they can resprout, or a deer isn't taking out the whole tree like it does with a seedling when it browses. So an ecological approach to oak regeneration, managing canopy gaps. Here's a gap in an oak forest. You can see these nice white oaks. And a gap, and it's really, trees will race to fill for that gap from the sides. And it's really going in and doing standard forestry practices to give those oaks a chance to assume that canopy gap. And that canopy gap could be formed by a snap off as pictured here, or a blowdown, or even a gypsy moth outbreak, or another factor that thins the forest canopy and allows a lot of light to come in, sets up a situation where oak and other species can race for that canopy gap, and we're going in and giving oaks the advantage. So as I mentioned, introducing fire, frequent low intensity ground fires after red maples have been controlled. We're recommending after a red maple has been controlled. Larger red maples, it can take many years to remove them just with fire. They seem to hold up well. The Morton Arboretum has been burning a oak dominated forest where maples are dominant in the understory for many years, and the maples are still there. So there are times when they can be taken out by a fire, but you may need to use forest management practices to remove the oaks and then reintroduce fire. So, and the circa 1800 forest, the survey notes from the General Land Office survey records, and verbal accounts written in the 1800s of our oak ecosystems here in Michigan describe very open conditions. So we have really dense oak forests, and I'm sure there were sites where fire did not make it to here in southern Michigan and elsewhere, valleys, north-facing slopes, steep topography that breaks up the fire, where oaks did not, did form thick forests. But most of the all of the accounts that I'm aware of describe these very open park-like settings for our oaks. So, in those settings, we are not finding oak regeneration in these thick, dense canopy, even if it's oak, and a dense understory, no oak regeneration. So what we see today may be somewhat of an anomaly. A lot of our sites, lots and lots of the sites that we've looked at, they were described as in southern Michigan as oak openings and oak barrens, and in northern Michigan, many of the sites were historically white pine, red pine, or red pine jack pine, or pine barrens, pine barren savanna with northern hills oak in it, or white pine, white oak. So they were mixed pine, mixed oak systems. The pine was harvested, slash fires came through and decimated the pine seedlings, and a lot of oak regenerated up there. So we have lots of oak where there was oak pine historically in northern lower Michigan. Today, pine is coming back. Pine is a component in many sites, and it's coming back. It's mixed with the oak. And those deep sands, I think we're doing okay up there. A little bit of forest management. We can continue oak for a long duration. Red maple is coming into those sites too, but in southern Michigan, it is marching full force, and has been for probably 50 years or so or longer. So I want to acknowledge my co-author, Jeff Lee, who did a great job collecting the data, summarizing it, and our field assistants, the collaborators, my former colleagues in the DNR for supporting the study, both financially, as well as lots of information on their sites, and same with the U.S. Forest Service staff. So I want to thank you for showing up today and for your attention, and I'm happy to take questions and discuss oak regeneration. Thanks.
Awesome. Mike, thanks so much. Really great. So let me start off with just a couple questions. Glenn asks, do you notice any deer browse differently on different species of oak?
I don't, I'm sorry, I can't answer that well enough. I suspect it's greater on white oak, less tannins, but I don't know if I don't. We may actually have that data, but haven't teased it apart, and that would be no small task. Well, it would be a focus task. We haven't done it though. That's
okay,
good.
Great, thanks. And then Jack asked, what are your thoughts about the current practice on a lot of federal lands in the Northeast Lower Peninsula of clear cutting huge, square miles plus of expanses of mixed oaks, purportedly for the purpose of oak regeneration? Seems wrong on so many levels, he says, but that's the excuse I've heard. Thoughts about that?
Yeah, and I haven't had a discussion with those guys, so I don't know what their motivation is or what their background is. So the forests, like, on the Grayling Outwash Plain, they're oak, so many of them are oak dominated, and they're generally low diversity in terms of herbaceous species as well. So I think if they're trying to move it toward a more like what my background is, this is on the Newaygo Outwash Plain, that are more savanna-like, where there's pockets of open savanna and there's pockets of forest and pockets of savanna with good ground layer coverage and diversity. I think that's what they're going for. I don't know what their financial objectives are, because that's always plays in. So all of these, like the DNR and Forest Management Service, Forest Service, they're funded by revenue from timber cutting, and in DNR and other agencies, the parks are supported by you're going to parks and paying your fees, and wildlife is supported by money from Pittman Roberts Act that comes back when you buy when you buy camo and ammo and rifles and so on and so forth, there's a tax, and that money comes back to the states based on the number of hunters. And so in other words, real estate division is supported by selling land. So they're not getting money from just general tax revenue. They're getting money from resources. So that I don't know where they're at with that, but that's an important component. But I've worked with state and federal land managers for years and have a deep respect for them. And I do trust, they're coming from the right place. They are concerned about biodiversity, just like I am and you are. They have other objectives, and I don't know where they're at with that. But if they're trying to regenerate oak, I remember having conversations with several foresters, and their understanding was that if they can cut northern hills oak, which makes up a lot of the oak in the Grayling outwash plain, it's not the only oak, it's white oak, black oak, red oak, black oak mixed with red oak, a hybrid. But they were telling me that Quercus ellipsoidalis would regenerate if they could cut it before about 70 years. And if they waited too long, it wouldn't resprout. And if it resprouts, that's successful oak regeneration right off the bat. That no matter how many deer you have, it will eventually reach the canopy. So they were targeting, they were concerned about the age of stands, the stand age. So, and if they could get in and cut before 70 years, then they could regenerate oak. So that was the thinking back. And we did this study back in, I think our first year of sampling was 06, 07. 06 and 07 was our sampling. And so you can add another 15 years to that. And now they're at a point where they've possibly, and I said, I haven't talked to them, but possibly they may feel like they got to cut it before it won't coppice, and they're only relying on acorn reproduction. So if you cut it early enough, you've got both. You've got acorns and you've got coppicing. So maybe that's where they're coming from. So
yep. Well, let's take that thread and go to coppicing. Ron asks, is coppicing a good or a bad thing? Is there?
Yeah, good question. It's more of a philosophical question. No, I'm just kidding. But so I think most of you know this, but so let me take a step back here. The prairies in the Great Lakes states, Illinois, southern Michigan, and northern Michigan for that matter too, and Wisconsin and elsewhere, Indiana, Ohio, Iowa. They were described as grasslands, but when you went in them, many of them were so thick with oak grubs. They were just incredible. I remember seeing a pamphlet from the 1800s of selling land, and it said, buy this land and in 30 years you'll have merchantable timber, because it was so chock of oak grubs. And the settlers talk about like every square, they used the term rod, 6 by 6 foot, every square rod had an oak grub on it. And they had it was easier to cut down a forest and grow than it was to remove the oak grubs from a prairie. So oaks, grubs, this is how they form. If you're at Kensington Metro Parks, there's forests there that are dominated by oaks where just lots of resprouts. And I'm guessing that was an old oak barrens that filled in with oaks that had resprouted. If you see a multi-stemmed oak, something happened to that oak. It was browsed, it was cut, it was grazed, or it was burned historically. So are they good or bad? I think they're the nature of oaks. They're part of the mixed.
Yep, great. So Steve, thanks for your comment that they don't like bur oaks as much. The deer don't like bur oaks as much. Bill speaks a little bit to the mesification of existing oak stands as an important stressor on their future, as well as invasive species. So any thoughts that you want, any comments to add to that?
Yeah, so mesification, the idea is that word mesification is when species that are considered mesic come into an oak forest. So it's not talking about the soil as much as it is talking about the tree composition. Red maples, sugar maples are considered mesic species. A mesic northern forest, a mesic southern forest is dominated by sugar maple along with other species like American beech. These are shade tolerant species, highly shade, they are our most shade tolerant species. versus oaks, which are not shade tolerant. They're on a scale of 1 to 10. Curtis put oak at about a 3.5 and maple at 10. So so the oaks are not considered mesic species, but they'll grow on any soil you give them, and most of maples will grow on any soil too. So there's a change in composition. The other thing that happens when the maples come in, they form these dense canopies, they impede light demanding species, and secondly is the oaks will the leaf litter will stick around for a while. They've drawn out the calcium before before the leaves drop in the oaks. They've sucked back in their calcium, and so the trees are taking up lots of nutrients, and the maples do the best job of recycling, or at least they do a better job than the oaks, because the oaks will hold on to a lot of those nutrients. They'll bring them back in the tree, and the leaves are very acidic and low nutrient by comparison to the maple leaves. They're thinner. They'll pump out the calcium, and then it falls to the forest floor, and they're bringing it up from the deep, and it's cycling, so it's adding more nutrients to the forest floor, much so than the oaks. So there's a big change, and that is the nature of it. I mean, it just doesn't it doesn't spell well for oaks. There's nothing wrong with maple forests, but oaks are disproportionately supporting more species than the maples, and have the potential to lose them if we don't do something to begin to allow them to regenerate. We have some time. They're long-lived species, but the understory trajectory does not look like it'll be a future of oaks in many sense.
Yeah, and then to that point, Sarah says very large clear cuts where we have good advanced regeneration is a strategy we employ in some locations in Pennsylvania for overwhelming deer and mitigating herbivory impact on regeneration. So there's some sound silvicultural reasons to do these large cuts. So again,
I hadn't thought about overwhelming the deer. Yeah, right.
Yep. And then again, thank you all for the comments in the chat and things like that. Mike, talk just a little bit about girdling. There's a little bit of conversation in the chat about girdling to control red maples, and can you speak just a little bit to that?
So there's probably some awesome stewards who have joined us too, probably would do justice to this question. But yeah, I think girdling red maples would be great. If you just got to be careful that you're not using the wrong kind of herbicide that goes through the roots to kill the oaks. But girdling oaks, girdling red maples, you probably want that red maple will generally sprout. So resprout. So you may need to use herbicide on that, but you can certainly try. I think that'd be great. In other words, you don't have to take the tree down. I think that's the essence of this question. Do you have to take the tree down? No, I think that's fine. The tree will serve as for cavity nesters, just like all the ash did for so long. And it'll be an important wildlife tree. And that would be great to leave it there. Yep,
great. So can you talk a little bit about the oak hickory balance? How does that, once you start to think about, adding in the hickories, and we've talked about maples, but talk a little bit about oak hickory for us.
Yeah, it's a good thought experiment, isn't it? So hickories are much more shade tolerant than the oaks. On that scale, they're about 6.5 to 7 generally, then compared to on that scale. This is by light adaptation numbers by Curtis in his Vegetation of Wisconsin, 1959. He has a table there called light adaptation numbers from his vegetation sampling of oak from his students. He was a professor at the university. He and his students sampling forests, all forest types across Wisconsin, and looking at light levels, measuring light levels. So hickories they're more shade tolerant, significantly more shade tolerant than the oaks, and they're part of our oak forests. So I think I'm not as concerned about hickory regeneration, but yes, we want to keep those in the mix. They're really important wildlife species. I wouldn't want to take them out. But what we need to do is we need to preferentially treat the oaks. We need to put those guys first for a little while. And would I want to take out a hickory to save an oak? In some cases, that might be the best call. If what you've got is good regeneration already of hickories and good representation and poor representation in the understory and sapling layer of oaks, then maybe that you might want to do that. I'm not talking about cutting down a big tree as much as managing those gaps, managing, looking for those specimen trees and doing what you can to the specimen oaks and doing what you can to allow them to assume the canopy at some point.
Okay, so I was about to ask you 10 more questions, and then I realized, hey, we've driven to the top of the hour here. So Mike, I want to thank you so much for joining us. Really appreciate it. And thank you all online also. Your comments and thoughts and ideas are add to the rich dialogue that we have here on the Stewardship Network's monthly webcast that we do each and every second Wednesday of the month during the Eastern Time Zone's noon hour. So you will find us back here on March 9th. Again, at the Eastern Time Zone's noon hour, put it in your calendar. Again, thank you all online for spending the time, and lots of thanks to you, Mike.
And thank you for the invitation to speak today, and thanks to everyone for showing up. I had a great conversation. All right, take care, everybody.
Okay, thanks, you too.
Bye.